In today's episode, we are building something really useful and it can solve one big problem that you most likely have come across if you do any work with cameras. Those annoying water drops on the lens that always appear on a rainy day or in any other case related to water. We can get rid of them with one really simple but expensive device, which costs around 4 to 5,000 USD. Basically, in front of the lens is one extra disc that rotates at a high RPM. When the disc rotates, all the water drops will fly off from the disc by the centrifugal force. The working principle is exactly the same as for any centrifugal water pump. We don't see this type of device often, but this is used in police drones, high-end Hollywood movie sets, and for media helicopters and those ones that record VRC rally, for example. So in this video, I will build one with the tools and materials that everybody can afford and solve the issue that I have had many times while recording my videos. Stay tuned and you see how I did it and will my version even work. Before we straight go into building, let me first show you the design. This is how the water drop deflector will look like. This is designed for GoPro Hero 8. But other versions of GoPro should fit in there too, because they are all pretty similar in size. Only the outer edge of the disc will cover the GoPro lens, because the centrifugal force is way stronger at the edge than in the center. So it should work more effectively this way. Also, it makes the design way easier. The disc is driven by 775 DC motor, because this is so simple to control, and it can spin up to 12,000 RPM, which is more than enough. When I finished the design, I printed the first prototype with Bambulab B1S and with their orange PLA basic. The point of the first prototype is to see any possible mistakes to fix them before I'm going to print the actual thing. And well, for sure I did some mistakes. Luckily, they were easy to fix. First, there was some gap that should not be there at all. It was 3-second fix. But the second mistake is big one. The GoPro doesn't fit in. When I was designing this, I fully relied on GoPro 3D model that I downloaded online. This is supposed to be 100% accurate, and for most part, it was. But the one most critical spot, those GoPro legs, were completely off. So I measured them by myself, and after 2 tries, I got this fixed. I didn't have any more errors with my prototype, and I felt comfortable to print the actual thing. For this, I'm using Bambulab B1S. And their dual coral silk filament. By the way, I choose this filament because it's my absolute favorite one right now and I just wanna print everything with this. But anyway, I'm printing with PLA silk dual color. Wall thickness is 3 layers and the model requires supports. So I am also using Bambulab support material for this one. Well, only the last layer of the support what actually touched the model. I am doing this because I need nice and flat surface finish. And using Bambulab support filament, it has worked every single time. Let me just show you. Bambulab filaments are freaking strong, and it was hard to break them off. But when I got the majority of the support material away, the last layer just peeled off. And like I told, the surface finish is absolutely amazing. You cannot tell this face was supported with supports. But I'm not done printing. I also need to print the door and the lid. I printed the door in severe angle with minimal amount of supports. It looks like this print for sure failed, but even for my surprise, the print finished successfully and the final product looks really nice. Now when the printing is done and we have the main housing, lid and door, we also need one thing that is not 3D printed. And this is the rotary disc itself. This one I got with 5mm thick transparent acrylic using my X-Tool PDU. Also this one turned out really nice. Now it's time to start building finally. This process is straightforward. We just need to screw a lot of M4 screws and we are done. The order of the assembly can be completely random. It doesn't matter at all with what you start. I decided to first screw on the lid and the door. Then I used 2 small M4 bolts to attach the 775 DC motor. And the final step, I had to use 4 M3 bolts to attach the acrylic lid to the coupler and then the coupler to the motor shaft. It can be a bit difficult to get access to the small set screws, but there is one designed hole for that. And now when all this is done, it should be ready. So let's give it a quick test. It seems to work fine. In low RPM at first I felt some vibration, but I think it was caused by some friction. Some spots of the disc touched the housing, but after this little spin, it wear in and I didn't feel this later anymore. This specific rain deflector is designed for GoPro. This will be pretty much press fit. This holds in there nicely, but for extra safety we can use the GoPro bolt, or however it's called. When the GoPro is in, there is one issue and one more issue that looks like issue, but it's actually not. What the fuck this and that? The issue is that I don't have access to the GoPro power button. And the other issue is that I don't have access to the record button. The last one is not a problem because I can do this. GoPro, start recording. GoPro, stop recording. Or use app to control the GoPro. Now it's final time to see does this device even work, and if, how well. So I strapped my GoPro to the tripod and sprayed some water to simulate rain. Right now I'm not using my device for control. Let's see, do we see those water drops that we try to avoid now. It is pretty clear that they are on the lens, and they do disturb the view. I know this would happen because these have ruined so much footage while recording my videos. So did we fix the problem? Let's see. Well, before we can see, I came across with a new problem. The GoPro don't hear my voice commands. GoPro, start recording. But eventually, I started the recording. So let's do the same thing, but now with rotary disc. And even for my surprise, it works way better than I expected. The disc is completely clean instantly after stop spraying. This is insane. Looking at the GoPro footage, there is no signs of any water drops, but we see severe vibration, so the device is vibrating and here is room for improvement. I saw the vibration a bit too late, aka when I was already editing the video. There would be one simple fix or at least improvement for this. GoPro Hero 8 have insanely good image stabilizer, but it was turned off. It was off because this is sometimes makes the footage a little foggy, and when I use GoPro I usually don't need this feature, so it was turned off while recording this video, but in this case this should be on. This for sure would improve the footage, but yeah. I didn't know this before everything was recorded. I also shoot the water jet on the lens, but when I did this, the water drops did make the way in. But this is pretty obvious why this happened. The water jet pushed the disc a little bit back and the side of the disc rubbed against the housing. This created a lot of friction and the motor didn't have enough torque to overcome it. So the disc stopped, and when it was not rotating anymore, the water made the way inside the device and on the GoPro lens. Even though this happened, I still can say this project turned out 90% successfully. The purpose of the device is not to overcome the direct water jet. This is to deflect the water drops that accidentally spray on my lens when I do water pump videos or record at a rainy day. The remaining 10% is the vibration. This is the biggest problem with the current device, but this should be easy to fix by improving the design to make it a little bit more rigid. So overall I'm happy how everything turned out, and I will use this one while recording my videos. This is the reason I even built it. So thank you for watching, and if you wanna download the model, the link is down below. Bye.